Is the sum 1 plus a half plus a third plus a fourth plus a fifth plus a sixth and so on finite? Well, no, it actually isn't finite. This sum here is infinite. You might think it's finite because, well, if you look at this term, first term is 1 divided by 1, the second term is 1 divided by 2, the third term is 1 divided by 3. Therefore, the nth term would be 1 divided by n. As we take the limit as n approaches infinity, 1 divided by n approaches 0. So you might think, well, since the infinitieth term approaches 0, shouldn't the whole sum also approach some constant value, since we're not adding anything at that point? Well, that's actually wrong. This sum is in fact infinite, and we can show that it's infinite using a simple method. We are first going to write out the sum. We're going to write out 1 plus a half,
plus a third, plus a fourth, plus a fifth, plus a sixth, plus a seventh, plus an eighth, and we'll do one more loop plus a ninth, and so on.
What we're going to do in order to prove that this sum is infinite is to write out another sum which you can easily show is infinite. This sum is going to be 1 divided by 2 to the power of r unless our value on top corresponding to the value on the bottom is greater than that, in which case we round down. So what I mean by that is, for 1 is 1 divided by 2 to the power of 0, so we're going to write that as just 1, plus a half is 1 divided by 2 to the power of 1, so we're going to write that as 1 divided by 2 to the power of 1. 1 divided by 3 is not 1 divided by 2 to the power of some integer, but it is bigger than the next 1 divided by 2 to the power of some integer, which is 1/4. So we're going to replace it with 1/4. Plus 1/4 is 1/4.
1/5 is bigger than the next 1 divided by 2 to the power of an integer, which is 1/8, so we're going to replace it with 1/8. 1/6 is going to replace it with 1/8. 1/7 is going to replace it with 1/8. 1/8 is going to remain as 1/8. As for 1/9, 1/9 is bigger than the next value of 1 divided by 2 to the power of r, which is 1/16, so we're going to replace it with 1/16, and so on.
Here we can see when we construct this second sum, we have 1 plus a half plus 2/4 plus 4/8 plus the next thing is going to be 8/16, and so on. We can see on the bottom, this corresponding term here is equal, this term is equal. However, the 1/3 term is greater than the 1/4 term. The 1/4 term is equal to the 1/4 term.
The 1/5 term is greater than 1/8. This is greater, this is greater, this is equal, we are greater, and so on.
We can see for every 1 divided by 2 to the power of r term, we have an equal sign, and for every other term, we have a greater than sign. Therefore, each term on top is greater than or equal to the corresponding term on the bottom. Therefore, if each term is greater than or equal, then the sum must be greater than or equal. Therefore, the sum of the top series must be greater than or equal to the sum of the bottom series. Considering the sum of the bottom series, we can see here we have a 1 and a half, so 1 plus a half.
Out of these 1/4 and 1/4, we get another 1/2. Out of these 4 1/8, we get another 1/2. And out of the 8 1/16, we will get another 1/2.
So therefore, the bottom sum is 1 plus a half plus a half plus a half infinitely. So therefore, the bottom sum is infinite. It's 1 plus an infinite number of halves, which is going to be infinite. Since the top series has a sum which is greater than or equal to the sum of the bottom series, and the bottom series has an infinite sum, the top series must also have an infinite sum. Therefore, the sum of 1 plus a half plus a third plus a fourth plus a fifth and so on is in fact infinite. That's going to be all for this video. If you're interested, there are other links in the description to other videos that you can watch. So that's it for this video. I hope you enjoyed. Thank you for watching and goodbye.